we have 1 over x plus 1 minus 3. Okay, let's do our numerator, denominator, and we've already done the vertical asymptote because that was in the other video, right? What makes our denominator 0? What's opposite of positive 1? Negative 1, right? So that's where that came in. Okay, horizontal asymptote. Okay, so for those of you guys that are like, well, the k's right there, yeah, but we're just lucky. Yes, it is negative 3. Okay, let's do it legitimately like I showed you here. We're on the middle one. If the numerator degree is equal to the denominator degree, then your asymptote is the comparison fraction of the leading coefficient, ANAD. That means the leading coefficient of the numerator over the leading coefficient of the denominator. And so that's why we're finding these out. Okay, so if I look here, you have this, okay, but we have to do it legitimately. Okay, so what I mean by that is, let me get another sheet of paper. I don't want anything there. Okay. Okay, see how this is not as one rational function. You have a separate term here. I don't want that. Okay, so how do you combine? This is really over 1. So in order to make it as one rational function, one rational fraction, I'm going to introduce the x plus 1 as a denominator here, right? So I get 1 over x plus 1 minus, and then I'm going to multiply, and I get minus 3x minus 3, and now this is over x plus 1, and now I can combine my numerators. Yes? Remember that? Okay, so I get x plus 1, and now what's my numerator? What is minus 3x, and then what's 1 minus 3, negative 2. So this is the equivalent to this, which is given right there. These two are the equivalent. Yeah? Okay, why do we need this? You guys just got lucky right there with that negative 3. Okay, what is my degree? What is my leading coefficient? All right, so when I look at my numerator degree, it's 1. What's my leading coefficient? Negative 3. Oops, let me put more space. Hold on. Look at my denominator. What's my degree? 1. What's my leading coefficient? 1. So if you're given a rational expression, a function, and it's written into multiple terms, not acceptable, you have to write it as one fraction, and there you do the comparison of the degree and the leading coefficient in order for you to find your horizontal asymptotes. Okay? Okay, so what does this say? If the numerator degree is equal to the denominator degree, which it is, notice the leading coefficient, the degree is 1, the degree is 1, right? 1 over 1. If the degrees are the same, your horizontal asymptote becomes a fraction of your leading coefficients. And so what's negative 3 over 1? Negative 3. And that is our horizontal asymptote. The next sheet you guys will get, I won't put them in separate little terms, okay? It'll now be, because we'll start factoring, they'll now get put together. So when your degrees are identical, numerator, denominator, it becomes a fraction of your leading coefficient. So what's negative 3 over 1? Negative 3, or you can just use it as the rewrite. Okay. All right. So if now I go to graph it, negative 1, negative 3, pink. Vertical asymptote is negative 1. Are you guys okay going by ones, or you want to go by halves, or are you fine with just by ones? Ones. Okay. So vertical asymptote, negative 1. horizontal asymptote at -3. Hold on. Okay, at -3. Yeah, I'm gonna have to. And so now you just pick points in the quadrant 1 and quadrant 3. So if you're at -1, you could pick 0 and 1. If you want to go for another one and pick 2, right? So for the quadrant 3, you can pick 1, -2, and you can pick -3 and just substitute, and that'll give you your curvatures. Okay, so if I grab a calculator, now it's up to you. If you want to use this, you can, or you can use the one from the top. What do you want to use? The top? Yeah, okay. So let me just type 1. And then what are we typing in? 0 first? -3, right? So, whoops, sorry. Right, so I'll type that. I plug in 0. Here, let me get my chart. I plug in 0. I get -2. So 0, -2 is here. If I substitute 1, I get -5/2, which is -2.5. 2.5. What did I plug in? 1? Yeah. Okay, so here are my 2 points, and this essentially is your curvature. Yes? That's your graph. Okay, if you plug in -2, wait, can you see? No. I get -4. And -3. Oops. -3.5. Oh wait. And -3.5. Okay, and there's your it kind of fits. Yeah. Okay, I'll shut off the recording right now. You guys can move on. Yes. Here, let me turn this off, you guys.